I feel bad that I wasn't able to record that other part for her. Okay, so part 2. Number 1, the graduate management admission test is used as admission criteria in many masters of business. Okay, score. A professor feels now that the score has improved within the last couple of years. So the null hypothesis is mu equals 529, and the alternative is mu is greater than 529.
Great. And then B, suppose you had evidence the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. And I put that it was a type 1 error.
Yes. So. All right, if the analysis was done at alpha equals 0.01 level, what is the probability of committing a type 1 error? And it said that it was the 1% or 1 in 100. Or okay. 0.01, right?
0.01, you got it. So if we want to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance? And we would increase the level of significance because if we wanted to eliminate the probability of making a type 1 error or decrease it, we would take that number down, which would change it. So it's the opposite way. So I put increase level of significance.
Yes.
Okay. All right.
All right, so we're taking this study in 2004, and according to the report, the average age of a person buying a second home is 47 years old. So I think I probably should buy a home soon, a second home.
Me too, I think so. I'm right about there myself.
Assuming the standard deviation was 5, the real estate agent wants to determine if the average age of those buying investment properties in his area is different than the national average. He randomly selects 15 of his clients who purchase an investment property and obtain the data shown. So A, design the study. What is the population? And it was the average people buying the investment properties. How did he sample this population? He randomly selects people from his own clients.
Clients, right.
Who and
just an investment property in the past.
Yeah, and the research question is the average age you purchase a second home as an investment rental different than the national average? Different than.
Yep.
I said he could do this by simple random.
Yeah, me too. I did the same thing. Okay. Describe the data, and I did an additional page where I did a bunch of graphs and stuff, so I don't know that we need to go over that necessarily.
Yeah, I just put it in my quantitative thing and got all stuff. And the QQ plot as well.
That made me crazy that I had to use SRSS because I didn't know how to do it. And I was annoyed that I couldn't open the file on the test. Sorry, I'm going back to talking about the test, but.
Oh yeah, I had to get SRSS too.
Yeah, that was annoying, but
hopefully
whatever.
We use it more than just that one time.
I didn't buy it. I just used the VMware and just flip back and forth. So, but it was a pain in the neck. So, because of course I'm right at the beginning of the test and I'm like, I don't know how to use this program. So I had to like teach myself really quick and then go on with the test, which was really but whatever. So, all right, let sigma equals 0.05. And then, so for me on number 4, I did my z-score, and my z-score was negative 0.207.
Well, yeah. To be exact, well, negative 0.2091.
Okay, and I might have had mine wrong, so.
Well, I did it the first time with using the calculation of 46.73333333 or whatever, and I got this 0.207. Okay. So yeah, that's good. And then the p-value You would have got 0.836. Is that what you got?
Yep. And then the next one I had the p-value is greater than sigma, so we fail to reject the null, is what I said.
Yes. And we have insufficient evidence to say the average age to purchase investment property is different in this area than the national average.
So, and then taking action, it's kind of whatever you want it to be. So I was like, when you're looking to sell an investment property, if you have somebody who comes in and they're 47, you're like, hey, I got an investment property for you.
Yes, target that middle age.
So, all right, very good.
Okay. I'm just going to go over our, I mean, you can go ahead and, well, I don't know. Should I go over the test, what we put down for
You can
the
want.
test?
That's totally up to you. You can look at it and you could say, just so that she knows what we put down as answers.
Yeah, I'll just tell her what we put down.
And then you can say, we missed a couple. I wouldn't necessarily tell her which ones we missed. I'd just say, we did miss two of the problems.
Okay.
Do you think that's fair?
Yeah, I think so.
Okay. So anyway, that way you're not
All right.
exactly what we got wrong, but what we did. So anyway,
Yeah.
Sorry about that. I hope you don't mind doing that. Do you have a problem going over those answers really quick with her?
No, I'll do it really quick.
Okay.
So that'll be fine. All right. Well, good to.
Yeah, sorry you have to go to an
Yeah.
appointment. Thanks for getting that done though. Actually, it worked out for me perfect because I'm taking my CNA boards tomorrow and I really need the time to practice. So
Oh, good.
it gives me a little more time.
Well, so next week,
Hmm?
my work schedule has changed. I don't get off work till 1:45 on Thursdays. So
Okay.
can you meet at?
You want to do like 2:30, like an hour later than we were doing now?
Yeah, is that okay?
Yeah, let me just check really quick. Yeah, that shouldn't be a problem.
Okay, I'll send that to Winsome and hopefully she can meet.
Yep, sounds good. And if she can't, we can try and figure out a different time.
All right.
All right, is that for this time or is that for every time?
For every time.
No biggie, I got it.
But I can get home as fast as 2:10.
No worries.
So, okay, it's not that much of a difference, but if she had to run somewhere.
Yeah, that's fine. But
All
I'm
right,
good.
Lori. Good luck with your test tomorrow.
Thanks so much. We'll see you later. Take care.
Okay, bye. All right, Winsome. I was just going to review what we put down for the test for the group meeting because it wouldn't record before. And so number 1, we put true. Number 2, we put true. Number 3, we put the null hypothesis. Number 4, we put the null hypothesis. Number 5, we put the null hypothesis. Number 6, we put that mu does not equal 10. Number 7, we put that mu is greater than 10. And number 8, we put that mu is less than 10. Number 9, we put that p-value is greater than alpha. Number 10, we put that p-value is less than alpha. Number 11, we put the average claim amount is greater than 1,500. Number 12, we put the average claim amount is equal to 1,500. Number 13, we put yes. Number 14, we put central limit theorem. Number 15, we put that it was the z-score. Number 16, we put the z-score as negative 0.900. And we put number 17, the p-value was 0.184. Number 18, we put failed to reject the null hypothesis. And number 19, we put type 1. Number 20, we put the probability of a type 2 error will increase. And number 21, we put alpha, the computing the probability is 0.05. It's what it is. So I hope that helps. I do want to tell you that we did miss 2 of those problems, and I can't really tell you which ones, but just know that we missed 2 and they were right in a row because we got them mixed up. So anyway, good luck, and let me know if you have any questions. Also, next week, I was hoping that we could meet from here on out at 2:30 Mountain Standard Time rather than 1:30 because my work schedule has changed. All right, good luck. Bye, Winsome. Hope you had fun with the test. Bye.